Hi KCET 2025 aspirants. So today we are going to solve the KCET 2024 paper. Okay, so previous year questions gives you an analysis of what type of questions are asked from a particular chapter, what level of questions have been asked. So we will discuss, and in this paper there were certain questions from the deleted portions. I'll be telling you that, and I won't be solving those questions. Okay, you don't have to waste your time in solving those questions. So I'll just tell you the question number and we will move towards the next question. Okay, so let's get started with the first question here, that is 0.48 gram of organic compound on complete combustion produce 0.22 gram of carbon. Percentage of carbon in the given compound is. So this question is from your stoichiometry chapter, or you can say some basic concepts of chemistry, right? So what is it? You have an organic compound 0.48, and when you heat it, you combusted it, you got 0.22 gram of carbon. Now if you remember, any organic compound, if it undergoes combustion, you get what? You get after that CO2 and water, right? And whatever is the amount of CO2 produced, from that we can calculate how much carbon is present in that compound, right? The amount of carbon dioxide gives you what information about amount of carbon present, right? About amount of carbon present. Now if you see, I have 44 gram of carbon dioxide, right? So you have 44 gram of carbon dioxide has 12 grams of carbon, right? Now if I have 0. So I can say 1 gram of carbon dioxide will give me 12 by 44 grams of carbon. Okay, next if I have 0.22 grams of carbon dioxide, that will be equal to 12 by 44 into 0.22. okay, so this much gram of carbon will be present. So I can solve it. 22.01 za, 22 2 za, 6 za, so 0.06. okay, so this much gram of carbon will be present. Now what is the percentage of that carbon? So percentage of carbon will be 0.06, that is the total mass of the carbon, divided by the total mass of organic compound, that is 0.48 into 100. So 6 1s are 6 8s are, and if I solve, you will get 12.5. So correct answer is option number C here. Okay. Next, in the sequence of reactions P, Q, R and S respectively are. So here there is bromine. Okay, okay. So now you can see alkene is there and 2 bromines are added. For that you need to add Br2 in presence of CCl4. If you add HBr, you won't get 2 bromine, so we can eliminate this option. Next, after that there is a Q where you have removed 1 HBr and you are getting 1 Br is there and 1 Br is removed. So that is dehydrohallucination. For that I need alcoholic KOH, that is there in both the options. Now after that you are removing another Br. For removing second time HBr, we need NaNH2, right? So that is NaOH. So this also goes. Correct answer will be option number D. And after that, if you use red hot iron tube, that is the cyclic polymerization of the alkynes, that will give you C6H6. Next, the first chlorinated organic insecticide prepared, that is again from your haloalkanes and haloarenes, it is your DDT. Okay. Next, this question is from the chapter solids, which is from the deleted portion, so not required. Let's move to the next question. This is also from the solids chapter, not required. You can move to the next question, but I'll just tell you MnO exhibits antiferromagnetism. Okay. Next, the number of atoms in 4.5. This is also from the solids chapter, not related or not required, deleted question. Let's move forward. Next, vapor pressure of a solution containing, yes, this is from the chapter solutions. Okay. Vapor pressure of a solution containing 18 gram of glucose and 178.2 gram of water at 100 degrees Celsius is. So you know, when you add a solute, the vapor pressure will decrease, right? The vapor pressure, normal vapor pressure of water at 100 degrees Celsius is 760. So the value of the vapor pressure of the water, when you add glucose to it, the vapor pressure will decrease. So I cannot have this as the option, right? Because this is more than 760. And you can easily make a guess that these two will also be not there, because the vapor pressure decreases to a certain extent. It is not like that 760 will become 7.6 or 76. Okay, so the correct answer for this question will be option number B by simple guessing, but I'll also tell you how to solve it. We have this formula, right? P naught minus P by P naught is equal to XB or NB by Na. During this type of calculation, we generally ignore the Nb in the denominator. Why? Because that is very less as compared to Na. Now let me substitute the values here. 760 minus P by 760 is equal to, what is Nb? Nb will be number of moles of B, right? So I can write it as Wb by Mb into Wa by Ma. Okay, so what is Wb value here? 18 by 180 into water solution, right? So in given mass is this one, molar mass is this one, then this is 18. Sorry, how much water is taken? 178.2 divided by 18. Okay, so I can do some cancellation here. Okay, next I have this side, I can say 18 by 178, I can cancel this 0 and this 0. So 18 by 178.2 into 76, okay, is equal to 760 minus P. Okay, now can I see something where I can find these numbers? So I can multiply, or 18, just let me modify it. Okay, so if I just multiply normal 76 into 18, okay, so 8 6 are 48, 8 7 are 56 plus 4 60, 1 6 are 6, 1 7 are 7, so I have 8 6 1368, right? So I will get 1368 divided by, I am putting 0 here, 1782. Okay, now let me divide it quickly. So in there will be some questions where you need to do calculation. Okay, so I can just write it this 13680 divided by 1782. Okay, now you can see you have to take all the 5 numbers. So you can try for 9, 9 2s are 18, 9 8s are 72 plus 173, 7, 9 7s are 56, 56 to 16. So it will go, 9 will become more. So 8, if I try with 8, 8 2s are 16, 8 8s are 16 plus 1 17, 56, it will also become more than 13. So I have to take 7, 7 2s are 14, 7 8s are 56, just a minute, 1 second. Okay, yes. So now if I just first multiply 1782 into 8, how much I'll get? 8 2s are 16, 8 8s are 64 plus 1 65, 8 7s are 56, 56 plus 6 62, 1 4, right? That is more. So I will take 7, 7 2s are 14, 7 8s are 56 plus 1 57, 5, 7 7s are 49 plus 5 54, 1 2 7 4, 10 minus 4 6, 0 2 1. Yes, next what will happen? We'll get this one 0. Okay, here I'll put a decimal. So if I put a decimal here, next I can take, you can see 1 2 4 was 7, so it will become 7.6. I can take 6 2s are 12, 6 8s are 48 plus 1 49, 6 7s are 42, 42 plus 4 46, 6 1s are 6 plus 4 10. So 7.6 something I will get here, right? So I can say 760 minus P equal to 7.6, and P will be equal to 760 minus 7.6. So something around 753 you will get, or 752.4, that is option number B. But without doing these calculations also you can easily guess the answer. Next, a mixture of phenol and aniline shows negative deviation. What is the reason for that? Because of intermolecular hydrogen bond. Okay, there is an intermolecular, you can see phenol is there and we have aniline. Okay, now there is a hydrogen bond between this hydrogen and this nitrogen and this hydrogen and this oxygen. Next we have, which of the following will show positive deviation from Raoult's law? So positive deviation means what? The interaction should be weak. So if you see methanol and benzene, right, methanol has strong hydrogen bonding among themselves, but when I add benzene to them, the disruption is there, the bonding becomes weak, so that will show positive deviation. Next, how many coulombs are required to oxidize 0.1 mole of H2O to oxygen? So if you see oxygen, we have O in the form of 2 minus, right, so that will give me, right, so I can say that 2 moles, I can say that 1 mole of O2 minus will be oxidized by 2 Faraday, right? Then I will have suppose 0.1, that will give me 0.2 Faraday. Okay, now if I just convert it 0.2 Faraday to coulombs, 96500. Okay, so I will get 19300 or 1.9311234 into 10 to the power of 4 coulombs. Okay, option number B. Next, a current of 3 ampere is passed through a molten calcium salt for 1 hour 47 minutes and 13 seconds. The mass of calcium deposited is, direct formula, m is equal to Z into I into T, or m is equal to molar mass divided by N into 96500 into I into T, right? So what is molar mass here? 40 grams, okay, divided by N is equal to 2 into 96500 into I value is 3 and time value is 1 hour 47 minutes and 30 seconds. So 1 hour is 3600, 47 minutes means 47 into 60, 6 sevens are 42, 6 fours are 24 plus 4 28, 0, 2820 and 13, okay, 6433. So I will have 6433 seconds. Okay, so now if I just remove this one, okay, so now how can we solve this? If I just solve this, you will be getting mass deposited, you can just calculate, you will get around 4 grams. Okay, the correct answer will be option number D here. Okay, for easy calculation you can make like 4 into 3 into 60, 400. Okay, I'm just making it so that, and this one I can make 9600. Okay, 9650 I'm just taking, so here I can cancel this one. Okay, next 2 32s are, and 4 2s are 424, 3 1s are 3 8s are, 8 1s are 8 4s are. Okay, so 4 grams will come here. Next, the value of A in the equation is same for. Now the value of A is same. Suppose you have 2 electrolyte 1 and electrolyte 2. Okay, it will have cation 1 and the anion 1 and the cation 2 and anion 2. If the charges of these cations and anions are same, then the electrolytes will have same A value. Now for example, if you see the first one, Na plus Cl minus, calcium 2 plus Cl minus, you can see the charges are not equal here, so this is not the answer. Here Ca is plus 2, calcium is minus, Mg is plus 2, sulfate is minus 2. Here anions are not having same charge, so it will also be not the answer. Here Na plus 1, Cl minus 1, K plus 1 and Br minus 1. You can see cations are having same charge, anions are having same charge, so that is why option number C here. Next question, number 13, for the reaction A gives you B, the activation energy is 50 kilojoule per mole and this is delta H. Okay, delta H value is minus 20. So delta H value is minus 20 means it is an exothermic reaction. So you have like this exothermic reaction, A gives me B. Okay, now what happens here? The activation energy given is 50 kilojoule per mole. Okay, and what is the gap? This one, that is your 20. Okay, now what we have done, now you can see when a catalyst is added, the activation energy decreases by 10. Okay, when you add a catalyst, the activation energy decreases by 10 joules. So now what will I can say that this value is now 40. Okay, now this value is how much? 40. This value from here to here, this is 40 now. So total was 50, 10 when you use catalyst, it decreased by 10, it became 40 now. Now the activation energy for the backward reaction means for B to A, what is the activation energy? 40 plus 20, that is 60, option number A here. Okay. Next, for the reaction PCl5 gives you PCl3 plus Cl2, the rate and the rate constants are given, the molar concentration of PCl5 at that instant. This is very simple question. I have rate is equal to K into concentration of PCl5, right? And rate value is how much? 1.02 into 10 to the power of minus 4, okay, divided by this side I will divide the constant, that is 3.4 into 10 to the power of minus 5 is equal to concentration of PCl5. Next, if I see, this one will become 10.2 divided by 3.4. Okay, so I can have 3 4s are 12, so that is 3 times. So your answer will be option number B here. Next, which one of the following does not represent Arrhenius equation? So we have the Arrhenius equation, K equal to A into e to the power of minus EA by RT. Right, now this is there, and if you see this equation, it is given positive e to the power of EA by RT, so that is why this is the wrong option. Next, colligative property, Tyndall effect, these are from all the deleted portion. Okay, the chapter that is your from surface chemistry, these questions have been asked, so we can cross, I can ignore this question. The same thing, this is also from the deleted portion, so don't need to study. This is also from the deleted portion, no need to study. This is also from your deleted portion. Next, this is also from deleted portion. Next, this is also from p block element, deleted portion, and oxides of nitrogen, this is also deleted. Then here also we have deleted, okay, no, this we can, this is also deleted actually, but you can say the answer very easily. That is when increases, the mass increases, the boiling point increases, right? So HI should have the highest boiling point, but in HF there is hydrogen bonding, so that is why its boiling point increases more than HI. Next we have, this is the synthetically produced radioactive noble gas by the collision of this one with calcium. This is also from periodic elements. The answer for this one will be your oganation. Next, the transition element with 5% lanthanoid, that is your mic metal, right? So we have iron. In the mic metal we have 95% lanthanoids and 5% iron is there. Okay, next you have to do match the following. So Zn2 plus has no unpaired electron, so it is a colorless solution. So I have 1 will be 2, so that is this one, and Cu2 plus has 1 unpaired electron, so its magnetic moment is this one, so 1.73, and Ni2 plus has D8 configuration, so that is option number B here. Next, which of the following statements about lanthanoids is correct? Incorrect. Okay, you have to find incorrect statement. So lanthanides are silvery white, that is a correct statement. Samarium shows +2, that is also correct. Ce +4 is a stable configuration because it is an I can say it is a noble gas configuration, right? So now Ce +4 are widely used as oxidizing agent. So if it is a very good, it is a very stable configuration, right? So it can come by the common oxidation states of actinoids and lanthanoids is +3. So it can come back to +3, it will undergo reduction, it will used as an oxidizing agent. Now color of lanthanide solution is due to DD transition? No, that is due to FF transition. So the incorrect statement here is option number D. Next, on treating 100 ml of 0.1 m aqueous solution of the complex CrCl3.6H2O with excess of AgNO3, 2.86 gram of AgCl was obtained. The complex is, okay, first let us calculate number of moles of complex. Number of moles of complex. Okay, what is the number of moles of complex? You can see, how can I just, you have in molarity and volume is given. So if I have molarity is equal to what? Number of moles by volume into 1000. So number of moles will be volume into molarity divided by 1000. So volume is 100 ml, molarity is 0.1 divided by 1000. Okay, so that will give me 0.01 moles, right? I will get number of moles of complex is 0.01. Now what happens, we have number of moles of AgCl, number of moles of AgCl. Number of moles of AgCl will be how much? You can see, first calculate the molar mass of AgCl, that is 108.0 and chlorine is 35.5. okay, so I have 143.5. So given mass by molar mass 2.86 divided by 143.5. okay, so 286 by 100 into 143.5 by 10. okay, so we will get here. So you can see that if I just multiply this one, 2 5s are 10, 2 3s are 6 plus 1 7, 287. okay, 2870. 2 5s are 10, 2 3s are 6, plus 1 7, 2 4s are 8. So I can say that 143.5 into 2 will be 287. So just let me, for easy calculation, let me just write down 287 this one. Okay, so then what it will be, I can write down this one will be 0.2, okay, and divided by 10, that will be 0.02. Okay, so number of moles of AgCl will be 0.02, and if I see this one, if I just divide the number of moles of AgCl divided by number of moles of complex, okay, then it will be 0.02 by 0.01, that is 2. That means 2 chlorine should be outside the molecule, right? Here I have 2 chlorine outside the molecule, so that is why option number C is the correct answer. Next, the complex compounds shows which type of isomerism. You can see SO4 and Br got exchanged here, so that is your ionization isomerism, option number D. Next, which of the following statements are true about COF6 3-? The complex has octahedral geometry. Yes, that is correct. Coordination number of cobalt here is 3. No, coordination number of cobalt is 6, right? So that is why it is incorrect. Complex is sp3d2 hybridization. That is also correct. High spin complex, that is also correct. Okay, so all the correct statements here are 1, 3 and 4. That is option number C. Next, a haloalkane undergoes SN1 and SN2 reaction depends on. So it also depends on the solvent used in the reaction. Okay, so if the solvent is polar protic, then generally the SN1 is followed, and aprotic we use SN2 mechanism. Next, 2-methyl propane can be, so I have 2-methyl propane. Okay, 2-methyl propane can be prepared by Wurtz reaction. Okay, the haloalkanes taken along with the metallic sodium and dry ether. So I have this one here, one haloethane, and this one Cl is there. So if these two will react, I will get this particular compound, right? So what are the 2 reactants I need? One I need chloromethane and another I need 2-chloropropane. So that is option number A here. Next, in which of the following you have to just identify the reagents. So C2H5Cl and X, it is your Schwarz reaction, right? For that we need metallic fluoride, so I can have this option and this option. Next, you see you have to remove this HCl, that is your alcoholic. KOH should be here. So here I have alcoholic, here I have alcoholic, here it is aqueous KOH, so this is also removed now. Next, C2H5 to C4H10, the number of carbons is increasing, so that is your Wurtz reaction, and we need Na dry ether. So here it is benzene, so that is also not correct, and here you can see Na in dry ether, option number C here. Next, 8.8 gram of monohydric alcohol. So you have one alcohol monohydric, okay, 8.8 gram. Is added to ethyl magnesium iodide in ether, liberate 20 to 440 centimeter cube of ethane at STP. So generally what happens, see, if ROH reacts with R dash MgX, so what will happen here? This one O minus H plus, this is R minus Mg plus. So RH is formed, okay, R dash H is formed, plus ROMgX is formed, right? So that is the product. Now in the given question, if you add ethyl magnesium iodide, okay, in ether, it liberates. So what I can do, this is minus, this is plus, so C2H56, so I will have C2H6 plus, I will have ROMgI, okay, C2H6. Now this one is told to you how much centimeter cube? 2240 centimeter cube, okay, 2240 centimeter cube. In this, what will happen? 2240 centimeter cube, if I am taking, I can convert it into number of moles of ethane that is produced. So how many number of moles of ethane is there? Given volume by molar volume, so 2240 by 22400, okay. So I will have 0.1 number of moles of ethane is 0.1. Now you see 1 mole of alcohol reacts with 1 mole of this one to give you 1 mole of ethane. So if the ethane produced is 0.1, then the number of moles of alcohols will also be 0.1. So from here I can calculate number of moles of alcohol is equal to 0.1. Okay, now given mass is 8.8 gram and we know number of moles is equal to given mass by molar mass. So what will be the molar mass of the alcohol? Molar mass will be 8.8 divided by 0.1, that is 88. Okay, now you see this monohydric alcohol when oxidized using PCC forms a carbonyl compound that answers silver mirror test. Okay, so that means this alcohol, this is an aldehyde compound, and aldehyde, so primary alcohols on oxidation will give you aldehydes, right? Primary alcohols. So you can see this is secondary alcohol, this is secondary alcohol, so we can eliminate this two option. Primary alcohol I need, so out of these two alcohol whose mass is 88, that whose molar mass is 88, that will be the answer, right? So I have 2,2-dimethyl propane 1-OL. Okay, so 2,2-dimethyl propane 1-OL. Let's calculate the mass here. 1, 2, 3, 4, 5. 12 5 is 60. Plus you have 3, 3, 3 and then 1. So total 10 oxygen, right? 1, 2, 3, 4, 5, 60 and then 3, 3, 9 plus 1, 10, 70. Okay, then you have 1. Okay, here I missed 2 hydrogens. Okay, so total I have 12 hydrogen and then 16. So that is giving me the molar mass of 88. So the correct answer will be option number B here. Next, when a tertiary alcohol AC4H10O. So we have tertiary alcohol with 4 carbon. So I have only one compound like this, right? Reacts with 20% of H3PO4, means that is your dehydrating agent, right? So it gives a compound C4H8. So C4H8 is formed as a major product. The IUPAC name of the compound is. So we have this one. Okay, so it is 2-methyl propene, option number D here. Okay. Next, PCC is a complex of chromium trioxide with pyridine and HCl. That is the formula. Okay. Next, propanol and propanol. Okay, so we have same number of carbons, different functionals. So these are functional isomers. Next, sodium ethanoate on heating with soda lime gives sodium ethanoate. So if you see, that is sodium ethanoate on heating with soda lime. Okay, on heating with soda lime, what will happen? Decarboxylation will take place and I will get CH3 and you can also have, it will give you C, means one H can be taken from here, you can get CH4. Otherwise you can also get, if CH3 radical is formed, it can combine with another CH3 radical to give you ethane. So we can get both methane and ethane, so option number A here. Next, butane on reaction with dilute H2SO4. So if I have butane, okay, and if you are reacting it with H2SO4 in presence of Hg2 plus. So what will happen? Water is added following Markovnikov's rule. Okay. Now here what will happen? This bond will come here, this one will come here. So I will get a compound like this, that is your butane 2-ONe, which is option number A. Okay. Next, biologically active adrenaline and ephedrine used to increase the blood pressure contain. So they contain secondary amino group, so option number B here. Next, aniline with NaNO2 and HCl. So that will give me what? N2 plus and Cl minus. Okay, so that is your P. And with phenol, what will happen? There is diazotization. So we will get a compound like this, N double bond N, and I will have like this, and here I will have phenol group. Okay, so that is your para-hydroxyazobenzene, option number C here. Next, the female sex hormone which is responsible for the development of secondary female characteristics, that is your estradiol, option number B. Next, the type of linkage present in nucleotides, it is phosphodiester linkage, option number B. So please remember here, in case of carbohydrates, the bond that is used between them is your glycosidic linkage, and this is an ether type of bond. Okay. In case of peptides, the bond is we call it peptide bond. Okay, and it is an amide linkage. Okay, and last one is your nucleotides. Okay, in the bond name is phosphodiester. Okay, and it is an ester linkage. Okay, so option number B here. Clear? You be clear. Phosphoester is there, diester is there. So be careful. It is phosphodiester linkage. Next, alpha D glucose and beta D glucose. So you know, in alpha D glucose and beta D glucose, the configuration is different only at carbon number 1. Okay, and if the configuration is different only at one carbon, they are epimers, and that one carbon, if it is C1, then we call it them anomers. So option number D here. Next, which of the following set of polymers are used as fibers? So this is from deleted portion, so we can skip this question. The biodegradable polymer obtained, this is also from deleted. Next, the compound name, this is also deleted portion. Okay. Next, cationic detergent, again some from your environmental chemistry, deleted portion. Uniform composition throughout the solution. So you'll have dilute aqueous solution of sugar, you will have uniform composition. Okay. Next, energy associated with the first orbit of helium plus. So we know any energy, En formula is what? Just let me write down here all the formulas. En is equal to minus RH into Z square by N square. Now what are those values of RH? En is equal to minus 2.18 into 10 to the power of minus 18 Z square by N square joules, or it will be also equal to minus 13.6 Z square by N square EV. Now you can see the options are given in terms of joules, so I will use this formula. For helium atom, okay, hydrogen helium, the Z value is equal to 2, and what is the N value? First orbit, so N value is equal to 1. So what will be here? En will be equal to minus 2.18 into 10 to the power of minus 18. Z square is 4 divided by 1. So if I multiply 4 8s are 32, 4 1s are 3, plus 1 7, 4 2s are 8. I will have minus 8.72 into 10 to the power of minus 80. That is option number B here. Okay. Next, our metalloid here is your Sb, that is your metalloid, which has both characters of metals and non-metals. A pair of isoelectronic species with bond order of 1. Okay. So if you remember F2, right, F2, fluorine forms one bond only, and I have told you how to calculate the bond order: 14, 15, 16, 17, 18, 13, 12, 11, 10. So if 14 is there, the total electrons in a molecule, then the bond order will be 3. Then below that you have to decrease by 0.5, okay, and this side also 2.5, 2, 1.5 and 1. Okay. So now if I see F2, in F2 how many number of electrons are there? Fluorine has 9, so 2 fluorine means 18, so 18 electrons will have bond order of 1. O2 minus, if you see O2, 8 plus 8 16, plus 2 18, and that is 1. So option number C here. Next, identify the relation for real gases. This is also from the deleted portion, state of matter. Okay, next question, from the diagram HR for the reaction, H1 value is, okay, this is your H1 value, A to B, okay, calculate C to A. Okay, now I have this reaction A plus 2B, sorry, one second, I can write this equation like this: A gives 2B, okay, what is the delta H value? Plus 10, okay. Next, 2B gives me C, here the delta H2 value is 25. Now if I add these two, what I will get? A gives me C, and that value will be 35. Okay. Now you want to calculate for C to A. C to A will be negative of this one, that is minus 35. So option number C here. Okay. Next, question number 55. In the analysis of third group basic radicals of salt, the purpose of adding NH4Cl. So you know this is a common ion effect. So if I add NH4Cl, what will happen? NH4OH will not further dissociate because of the common ions here, right? So that is why option number C. Next, solubility product of CaC2O4 at a given temperature is given. Solubility of CaC2O4. So if you have CaC2O4, how will it dissociate? To give you Ca2 plus and C2O4 2 minus, okay, that's the solubility be SS. Now what is the Ksp value? That is equal to S square. And what is the KSP value here? 4 into 10 to the power of minus 9 is equal to S square, and I have 4 into 10 to the power of minus 9 root over is equal to S. So I can just write it in the form of 40 into 10 to the power of minus 8. Okay, sorry, just a minute, 40 into 10 to the power of minus 10. Okay, so now I can write this. 40 square is 6 square is 36, right? 7 square is 49. So 6 point something into 10 to the power of minus 5. So that is your option number A. Okay. Next, in the reaction between moist SO2 and acidified KMnO4 or permanganate ion solution. So you know KMnO4 is a strong oxidizing agent. So SO2 will get oxidized, MnO4 will get reduced, right? So SO2 is oxidized to SO4 2 minus, MnO4 is reduced to Mn2 plus. That is correct because it is in acidic medium. SO2 is oxidized to S. No, here SO2 is undergoing reduction. If you see plus 4 to 0, it is reduction. So that is wrong. SO2 is oxidized to SO3 2 minus, MnO4 is reduced to MnO2. No, in acidic medium MnO4 minus is reduced to Mn2 plus. Next, SO2 is oxidized to H2S. Here you also see it is plus 4 to minus 1. So it is not oxidation. So that is also wrong statement. Next, which of the following properties is generally not applicable for ionic hydrides? So you know ionic hydrides are generally not volatile. The bonding is very strong. They are non-volatile. So option number D. But this is also from your deleted portions. Next, which of the following nitrate ion will decompose to give NO2 on heating? This is also from deleted. Answer here is lithium nitrate. Next, which of the following hydrides cannot be hydrolyzed? This is also from deleted, but the answer for this one will be CCl4. Okay. So students, there were many questions last year from the deleted portion, so that is why the paper evaluation was something different. But do not worry, this year there won't be any question from the deleted syllabus. If any question comes from the deleted syllabus, you can leave it or you can just put a random guess. Do not worry, and do practice the high weightage topics because we are just left with 1 day for the exam. So let's put our 100% now. Okay, that's all students, and all the very best for your exams.